See.
Yep.
Yeah.
You just mirror your displays.
Well, it's a little bit strange because it's not.
What? Well, keep going.
Oh. Well, let's try with the slides and then
Yeah.
we will
There's
see.
different setups because you can do mirror displays. Sometimes that doesn't work because the other graphics card.
No, you should pick up the lower one though. It'll change both to the lower one. It's usually,
That's what I hate. So you're looking at your screen,
yeah, your beautiful screen is now whoosh.
and then you're like, "Come on, where's my terminal?" And the other one, some of these, it does the external one as a separate desktop.
Yeah, which you can do. You have all
Okay.
the slides?
Yeah. So this should work. Let's see. There are quite few, essentially. Now is the.
Correct. The presenter stuff is on your side. Good job.
Oh,
Was all good?
really? Yeah.
Yeah.
Well, the aspect is not precisely the, and the colors are not precisely what they should, but well, anyway.
Well, that's a projector. Yeah.
Yeah. Okay.
Microphone.
So well, it's about time.
Show here's not bad.
Yeah, but there is not good. Anyway.
That's amazing.
Okay. Take a seat, Stuart, please. Okay. Whatever you feel like, but close. Okay, it's about time to start. Welcome. This is Nfvrg. And we today have a meeting in which we have basically 3 presentations from different research activities. As usual, this is a reminder of the IPR policy and the equivalent to what is the Note-well in the IETF. And as usual, is a request for you to be active reviewing documents, though we have not very many documents active right now. And this is as well a reminder, it's not said here, but it's a reminder to you to be a little bit more active in the list that is becoming too quiet lately. Just a list of what you are, the different links that you have for accessing the slides, access remote participation, and information regarding the collaboration tools that we have in the group. And now is the moment in which I have to ask for anyone that is willing to help us in taking notes. That's as active as the mailing list. Can you take care of taking some notes, sir? Okay, at least the lady to my left, that is Sarah Banks, that is normally is our secretary and is our perfect note taker, and is acting as a co-chair today. And well, again, this is something that is a notice that we always show precisely about the research-related events. You know that you can use the list to make announcements on research events that are related to what we're doing here. And well, the idea is that you have to exert some self-control on what you announce, and this is something that, in case of doubt, we will be happy to help. And well, that's a few news and a few updates on how things are going on inside the Nfvrg. First of all, is that the GAPS draft is close to go for IRSG poll. We found, actually, we found 4 reviewers. We needed 3, and we found 4 reviewers that review the document. Almost before coming here, I have been acting as a shepherd of the documents, and almost all comments, but 2 that were more worth a little bit of discussion with the reviewer have been addressed. Very likely, at the moment we are back from this meeting, I hope, Carlos, the GAPS document will be ready, right? When we are back.
Yes, Carlos, yes. We are just working on the very last comment that we have left, and then we will submit a version like maybe this week or maybe next week, but no later than that.
Okay, thank you. So, and then I think that we should start thinking about future documents. We have a couple of them that could be could evolve. One is the one that started as an analysis of the application of containerization to NFV. That then we have had contributions from, if you remember, from in Buenos Aires, we have a discussion on the application of mini kernels and microkernels for NFV. Today we will have a presentation of this as well, and I think that we have a good opportunity precisely to make a significant contribution in an aspect that is about precisely re-architecting NFV. That is one of the goals that we have in the group. What we need are editors and additional contributions, and you are most welcome to come to us and tell us what do you think and whether you are feeling to volunteer as editors.
So, Carlos Bernardo, on that particular thing, I will be personally interested in contributing in any way that you think may help.
Okay, so your name is written down. Thank you. You're on the list. Another that I think could be is a reasonable measure as a contribution, but I doubt that it could be a contribution, a direct contribution to Nfvrg as it is, because it has a very focused and limited scope. It's on service validation and service verification. Sorry, I use validation and we're talking about service verification. I think that Myunki is here. Yeah. So this is something I would like to discuss with you later on, is that I think there are potential places in which we can bring this even to the IETF. And this is something that we had to explore a little bit and discuss, because SFC, I2NSF, or even there is a there is something that we are trying to start on attestation in general, and probably would be there would be reasonably good places to contribute this. This is something that we had to discuss. Finally, well, this is a list of other activities that I consider that are interesting in the happening on the IETF 100, not 99. Sorry. And well, you have there a list. There is you know about, well, IDEAS is about identity-enabled networking, TIP is on attestation precisely, Nfvrg network management. There was an interesting session this morning, PANRG on path-aware networking, the activity on STAR on short-list certificates that I believe will be essential for security in NFV. There is a side meeting on edge computing. Well, whatever other idea you have, it will be welcome. And finally, this is the, again.
Sorry, just one question on the edge computing side meeting. Do you know when it is? Or?
On Thursday, if I remember well. Let me, I'll check and I'll announce it during one of the, while the speakers are changing. And well, finally, this is the agenda. As I said before, the idea is to have 3 introduction to research activities that are related to the goals that we agreed to have in our last meeting in Prague. So first one is precisely on this re-architecting, which is a new view of the re-architecting task of NFV. Second is very much connected. The 2 others are more connected with the new orchestration stacks. One is about the inclusion of some mechanisms for self-adapting the systems, and the second is on slicing and how you can dynamically create slicing by doing fancy things with the virtual infrastructure managers. Time permitting, we will have at the end an open mic period for whatever idea or discussion you want to open. So let's start with the first of the presentation. Is Eduardo Jacob from the University of the Basque Country. Venme avisando. Okay. ¿Y esto para qué? ¿Seguro? Bueno. Allá tú. No, wait a second because I had to open the. No, doesn't work.
No.
No, doesn't work. It's telling me that it won't work.
Okay.
It's a Mac, exactly. One second. Here you go.
Well, good evening. Well, I am Eduardo Jacob. I'm going to present some ideas we have been working with. This is the agenda. I will take a look at how we understand NFB and how we have arrived to this new view on what NFB we think should be. We will take a look at the evolution of the technology, proof of concept we run in ETC, some limitations we have found in the actual definition of NFB, and some pointers to a solution. Just to go, this is just if you ever wonder where the University of the Basque Country is located. It's in the north of Spain, but it's in there, so just go ahead if you want some information. Next. Well, if we take a look at NFB as a technology, we all remind that the idea was replacing dedicated equipment with commodity computing hardware and switching elements, which in fact meant that we had a common hardware base, mainly computing nodes and switches, and on top of them we deployed other pieces of software that would act as brass or whatever we needed. This meant, in a certain way, going to cloud technologies, and meant, if we take a look at the networking aspects of it, manipulating them in the user space, or at least in the virtual machine. Well, originally the network was clearly static, as is happened in the cloud world. I mean, this meant that in a certain way it was pre-configured for all, even if later we had SDN as a way to configure more or less on demand at the throwing of a network service to be configured on demand. Okay. If we take a look, this is the NFB architectural framework, and we can see NFB like it was really thought. Virtual network was to be deployed over a network hardware. Virtual storage was to be deployed over network storage hardware. It was quite easy because, in fact, it was always speaking about blocks, so virtualizing this was quite easy. Virtualizing computing was also quite evident, and virtualizing network was not so easy, but, well, we had some tools for doing it. Well, this had some implications. The implications were that if we were willing to process packets, they needed to be done on a computing node. At a certain point, we need to take out the packets from the network, throw them to the virtual machine or whatever we have here, and send them back. This has one important implication, is that we are not able to treat the packets outside of a data center, outside of where a computing node is located. Well, so we start to thinking about how it would be possible to get a more efficient packet processing. And here we found what really happens. We have computing nodes, we have switches, but the switches are only used to redirect packets to a VNF, virtualized network function, in which the process, some process here manages the packets and send them modified or not, or discard them as the need of the VNF. I'm not going into details of what VNF is. It's for now just some kind of CPU-based, general purpose CPU-based processing. Okay. Well, there are two competing approaches to process the packets more efficiently. One of them is using general purpose CPU processors, which is the original way in which NFV was thought. But we could also speak about enhanced data planes. To make things even more spicy, we can also implement data planes in general purpose CPU. So we have some kind of mixed approach here. If we take a look also at the hardware involved in a plain NFV, we have some ideas regarding computing boxes and switches. Perhaps we could say the price for port is much higher in computing boxes. That's true. You cannot think about implement a general purpose switch with a multi-NIC computer software because that would be expensive. We also have the idea that the switches don't need a very special, in many cases, place to live in. That's something the environmental properties are more tolerant for switches. We also have the idea that changing the process inside a switch is much more difficult than in a process. Also, these are more or less, this could be varying depending on which kind of technology you use. Well, we are going to take a look at a very high view. This is not a full review. I mean, there are things that are missing. I could not put every link, so I have only left some ones I think that could be more interesting. If we take a look at the processing capabilities on the data plane, here we have, I choose OpenFlow because on a certain plane, I think that at least for now, processing in the data plane in a general point of view is more or less bounded to OpenFlow. And we have different approaches. We can start with ASIC manufacturer for 50-part switch manufacturers. Broadcom 3.2 is this kind of ASIC that you can find in many switches, and you can find more or less the equivalent set of properties or features in all the switch manufacturers. You have vendor-specific ASICs. This means that you can have different features, for example, custom pipelines or whatever. You can find numerical processors-based switches. Nfvrg is one of those manufacturers. You can have FPGA, and you can even have x86-based data plane, XDPD, OpenVSwitch, CPQD switch, whatever. This also gives you some ideas, for example, in terms of, once you get the list, you have one property that is important, it's one limitation. There is not only way to describe the processing you need with the packet. Those approaches are not using the same language, are not using the same model. They are totally disjoint in many of the cases. Also, in a certain way, adding features is more and more difficult, more and more easier. If you go here, it's more easier to add features than if you are here. Well, if we go to the last of these architectures, we can say that there are many activities regarding giving the property of a stateful processing. Having a stateless processing, and we don't consider methods, we don't consider groups, means in a certain way retaining a state. OpenFlow switches are many in a stateless, and if we want to give them some stateful properties, there are several work in progress. The first one is implemented over CPQD switch. The second one over OpenVSwitch, and the fourth one is being implemented before as a general switch with Tofino Barefoot chips, or even with NobiFlow as I think it's NPU5. Well, one thing that is important is most of them, except perhaps before, is an very experimental approach. These are things that have been treated but not used very much. If we take a look at how the packet processing is done in the computing node, we found that one very important thing, it's done with x86 code. I mean, we can speak later about the environment, we can speak late about many things, but we can say that at least there is a lingua franca, which is that some kind of code which can be interpreted. Normally, we are trying to get an environment that is smaller, that is quicker, that allows speed processing, and has reduced the memory footprint, that's very quick in order to set up and boot time. And we have, well, the evolving, if you go from hypervisor to virtual machine, to containers, to unicursors, perhaps ClickOS and Mirage are one of more or less known. As before, this also means some kind of things regarding the weight of the solution, regarding the security. There are many things. I mean, most of this decision or most of this alternative is not very equivalent. Well, as before, all these technologies are able to take profit of low-level packet processing improvements. There are several technologies that are being developed. Most of them involves bypassing the TCP/IP stack, and many are already being integrated in other software like OpenStack. We have internal processing with XDP. XDP is Express Data Path. This, just to give an idea of where it gets the packet processing, is get the packet processing features by integrating extended Berkeley packet filters, which is kind of code that can be run at kernel level. We have user space solutions like NetMap, DPDK from Intel, and Snap. On all those approaches are more or less integrated in more or less all of these, one or the others. They could be equivalent in some points, but well, we can say that there are improvements that are going to benefit these approaches. So this means that at a certain point, both technologies approach. We have some also expectations on the CPU evolution. It's more than going for more speed and more cores. Last Skylake architectures have 16 or 12 cores, but also on hybrid approaches. There have been experiments with Intel Core Xeon and FPGAs, but as far as I can say, it's more targeted to data processing, not so much targeting packet processing. So there are some conclusions. The boundaries between computer and switch are no longer equivalent to data and packet management ability. The more subtle difference is related to the state. Traditional switches are stateless. And this is true, but some new players involve a stateful solution on both silicon and software switches. We can say that there are champions on each specialty. Classic VNFs are the king of stateful processing, while switches are the queens of stateless processing. Well, so the conclusion is there any place for an hybrid virtual network function in which we can process the information in both a compute node and a switch? We think that yes, there is. That there is a place for improving current architectures. And now let's take a look at the proof of concept we ran in Etsy. This idea started some time ago. We published a paper and we take a look at how the things were running. At a certain point, we call SDN agnostic NFV, that kind of VNF which was deployed without taking into account the underlying network. Later, we had an SDN-aware NFV in which the network service could ask for some kind of network configuration and couldn't get it. And finally, what we begin speaking with about SDN-enabled NFV, in which part of the processing was passed to the VNF, which is the stateful processing, and the stateless processing was in the switch. Well, the use case for this POC proof of concept was flow-aware network access control. In the two first approaches, all the traffic needs to go to the switch along the authentication data. This was currently .1x. You get to the VNF, and depending on the result, part of the traffic is resent and sent to the network. This means that at a certain time, all the traffic is processed in the VNF. If we go to the SDN enabled NFV, we send to the SDN switch both the traffic and the authentication data. The authentication data is studied and maintained in the enforcing block. There is some configuration sent to the SDN switch, and only part of the data is sent to the network. We take a look at how this was implemented. We run the POC with Telefonica, HP, Kinetica, and UPV. And we demonstrated the improvements we could get. This was demonstrated in two places, in Bilbao and Paris. And here you have a representation of the name service we were using, the network service we were using. We have a test user, which is the VNF that generates the traffic, the VNF, the test service, which is the VNF that receives the traffic that is going from here. And you have here the FlowNAC VNF. We have an enforcement. The enforcement is the part of the VNF that decides to pass or not to pass the traffic. And we have a control, which is also part of the VNF. We deploy this into different servers and on a switch. 3 scenarios. This is the first one. In the first one, we have, this is one server, this is another server. We have the two VNFs, the user and the test. We have here the traffic that is going out, goes to this virtual machine along with the authentication traffic. And here we decide which kind of traffic must pass, and the remaining traffic is sent back to the user. Okay, so we see this is the first approach. Next, please. The second approach, we did use some enhanced placement awareness. That meant that we were able to put the virtual machines on top of specific places to do a specific placement, and we could use, for example, pass-through features and SR IOV to improve the benefits. And we got very good results, but we still need to pass all the traffic to the virtual machine. And the third one, what we used was, you see now the traffic only goes to the OpenFlow switch, and the authentication traffic goes to the controller, and the controller configures the switch to let pass only the traffic that is involved. The conclusions, you can take a look here. These were bad numbers. We are now very much improved. We almost get the same numbers regarding the speed of the links. But the important thing is not only the speed of the links, but is the number of ports you use and the needs or the number of cores you use. In the third scenario, you don't use any bandwidth communicating the two elements, while in the other you need it to communicate both elements by links. There is also one important thing. Here you needed a core almost full time used for doing the forwarding, and now this core is no longer used because this is done by the switch. There is one important thing. The authentication traffic, just to get an idea, is around 5 kilobytes per re-authentication. And there is one important thing, is that the control function can be topologically decoupled from the enforcing point. This means that we have a split VNF in which we have a controller here and we have the enforcer here. This means that we are going to this architecture and we have one component in the compute node, and another one is done in another part. Well, this is our experiment, and now I would like to highlight some conclusions. We get the limitations. We understand that when we speak about NFV plus SDN, I think that NFV is usually written in bigger letters than SDN. And that's it's perhaps because SDN was incorporated later, and the network was not considered to be part of what the user could define. This is due to several reasons. Many times, delegating the control of part of the network is not an easy task, not only from the technical point of view, but also from the administrative point of view. If we take a look at what this really means that at a certain time, at a certain point, the network service, which is running in this component, is part of the user definition of the problem, but we have an infrastructure. We could be the logical switching instance 0, one lower instance, over which several logic instances of higher level are running. Another limitation is that we normally understand that the networks tend to reorganize itself if we begin placing packet processing elements on top of the network. We enter the placement game, which is quite difficult if we are using a network, because there are some delays that you should take into account, and the service could be impacted. Another thing that the BNFD and BSD descriptors do not contemplate processing outside the computing node. And this is also, as I already pointed out, there is a problem with packet processing. There is no lingua franca for defining packet processors over the full set of possibilities we have.
1 second. No, sorry.
Okay. And well, the pointers to the solution, I think this is not a closed list, but what I really think is that we should try to rewrite the equation, trying to give to SDN the same importance we're already giving to the computing part. It's more than NFV plus SDN is trying to really think about both parts of the equation. In fact, that could mean considering the network really becoming part of the software involved in the network service provisioning. Just imagine that you could get, for example, ciphering as part of the link description you get on a name service. You say, I need to have this link cipher, and that involves deploying that functionality on the very specific part of the network you want. You could also implement advanced slicing mechanisms more easily, because you could really slice at the point you want. Just imagine that you could ask for a link, for example, to have VLAN conversion that could have also tunneling, suffering, or even providing resiliency just in the definition of on the network service, have this sent to an orchestrator, and the orchestrator configure this, not only but putting flow rules, but also deploying code. Things, well, the network equipment should be able to virtualize its resources. Nowadays, we have found that it's easier to virtualize on software switches than to virtualize on ASIC switches. It's not so easy to stack open flow switches over open flow switches on real silicon. I think that recursivity is something we have already studied in the past, and it's important. We really think that we should not think that this is an enhanced platform awareness problem. It's more than that. And we really think that, well, it's not an easy term, an easy solution. Please.
That's all.
And that's when doing research. I think that's something we tend to think about research in that way when I hopefully think it is not. Thank you very much.
Okay, thank you, Eduardo. So now is the moment in which you should be lining up on the mics. Thank you for paying attention to me. Sorry?
Hans Link, Nokia. Did I understand correctly from your slide that using containers or virtual machines is irrelevant for your purposes?
Excuse me?
Containers, virtual machines. There was a statement that it's that the format of the distribution of code is not relevant. Are you saying that you don't see any differences between using containers and virtual
No.
machines? And
No.
if so, okay.
No. That was not my. If I told that, it was really not my idea. What I was trying to say is, if you consider virtual machines, or you consider containers, or you consider unikernels, at a certain point there is some similarities in the code you can use. I mean, you can use C, whatever, and this, you're pretty sure that this C would compile more or less the same because you're using the same GCC compiler on any of the approaches. But of course, the core placement is critical, of course, I think, if you are dealing with the network interfaces.
Okay, good. Related question. What is your feeling about the isolation when we are talking about, for instance, network slicing? Does this approach impact the isolation of flows?
And in which terms? When speaking to over the switch or
over the switch, sharing the connectivity.
I mean, finally, it depends much on the switch features you have. If you have, for example, a switch that offers meters, you can isolate, at least from the performance point of view, slices between them. That's kind of. As I tell you again, this depends very much on the underlying technology. At least, I mean, we don't have at the university, we don't have every brand of switches, but we had the problem because it's difficult to share the control, for example, of different OpenFlow instances. It's not so easy. So I think that at a point, there are some times that, at least our experience, that you are bounded by the implementation of the switch. But I really think that in the near future, for example, you have elements that could give you some, for example, performance isolation. I mean, you can flood one part of the switch, not affecting the other. That kind of isolation could happen.
Okay.
Thank you.
Wolfgang Beck, Deutsche Telekom. We've been doing such things for some time now, and the conclusion is generally Intel CPUs are nice and they get decent speed, not great speed, but decent speed, but they use pretty much power. They have much power requirements, which might be a problem for us. You get better metrics for power consumption and speed with proprietary hardware, but then you have always proprietary variants of those protocols like OpenFlow or even P4. We had high hopes in P4, but we did some implementation and it turned out for P4 equipment A, we had to use completely different code than for P4 equipment from vendor B, because they have just different kind of resources which get exhausted how you are coding your code. So you can't really do vendor independent stuff today.
Yes, I think that's one of the problems you have. You don't have I mean, you are never comparing oranges to oranges. That's the problem. They're moving different things on. I mean, if you are trying things over the same server platform, x86, Xeon, whatever, with 2 Intel NICs, the power consumption, the CPU occupation is something that you can really compare more or less easily. for a given solution, but it's not easy because it could happen what you say, that perhaps one specific piece of software gives a better result than another one, or some specific configuration. So I really think that, from the point of power consumption, perhaps some activities could be improved if you're using switch elements. If this happens to be P4 in the future, something that I really would like to see, because that could be a lingua franca, that could be also some kind of general architecture. That could be easier. That would be easier, but we haven't tried it.
The language alone, both vendors implement P4 perfectly, but
Yes, but it's the problem with P4. You compile or you treat, and you can have P4 over Tofin, and you can have P4, if I understand, also over Nobiflow NPU5. So these are different. It's more or less like C. What is C? Or what is the
it's a bit
speed
like
of?
doing C programming for an 8-bit CPU or a 64-bit CPU.
Totally agree. Yes. Thank you.
Kyle Rose, Sandvine. So we've been talking about, I think towards the end, about decoupling the sort of control plane from the data plane and doing infrequent decisions in the slow path, so to speak, and then processing every single packet in the actual OpenFlow switch or the ASIC or the whatever. That is kind of what you got at with the last bit of the presentation, correct?
Sorry, could you repeat?
Right. You're trying to present a strategy for doing NFV where portions of the hard decision making is done infrequently on the actual the general purpose compute hardware, and then the high speed every packet processing happens in the more special purpose hardware. Correct?
Yes.
Do you see any value in researching what is possible to do in that special purpose hardware, like a minimum set of functionality that should be provided in order to meet certain use cases?
Well, I think that, for example, I think it's something I tried to mention. I think that the facilities you have nowadays to virtualize general purpose operating system of a general purpose hardware are not available in switching. You have a bunch of limitations if you want to do that. At a certain point, I will not name the brand, but we wanted to run OpenFlow instances over a switch. There was not the possibility to put logically a switch on top of another switch. We had to run a cable outside the switch for entering the other instance. This is a pain. This breaks the programmability of the approach. So, for example, something that could be done at the research level was to think also the switching platforms to be able to be virtualized, to be able to run classical instances, several OpenFlow instances, to be able to stack one of the other over the other, to stack the control. There have been research done about that, and I think that's something that is promising.
Thanks.
Thank you.
Okay. Thank you, Eduardo.
Thank you very much.
Next one. Let's talk. By the way, two things. Don't forget to fill the blue sheets. And second, the edge computing thing is on Thursday at 8. Where? I don't know. That's something that's... Pedro, I don't know what happened with the video. No, it was my computer. Sorry. Now I have to open the... So in despite of his name, his aspect, Pedro is Japanese in practice.
No. Still not.
So he's... No, I know. I'm changing it. You can start introducing yourself or whatever. And,
Okay. As you probably know from the slides, no? My name is Pedro Martinez. I come from ICT, Japan, and I will present some research efforts we are doing in terms of exploiting a set of measurements from different places, not just network resources, in order to actually perform the elastic adaptation of this SDN and NFV more flexible systems, no, to dynamic service demands. Well, I will first start with a brief description of the motivation of the research topic of this work and our proposal, of course, and I will then align that proposal with what I suppose most of you are more interested in, is align that with the NFV management and operation structure. And finally, I will conclude and give some hints on the future work. Okay, next please. First, this is a bit obvious, but as you probably know, we are in a world where resource demand is not continuous. We have a high variation on it, and but normally, in general, in the past, especially not today, but in general, we are more happy having fixed resource allocation. They are easier to manage, they are easier to decide, etc. But it is not optimum, so we have to answer it with some kind of elastic resource adaptation. As we have found in cloud computing, in many environments, we have this kind of elasticity concept, but we are trying to even go further in that sense, because normally they are not meeting the actual demands of networking in terms of autonomously, etc. So in this use case, I will show how can we deal with a different how to deal with a problem in the network that is happening after one incident, an external incident happens, like for example an earthquake, and how to actually react to that problem before actually the users of the network are increasing the use. In this case, we have one help desk that is waiting for users that can attend when something happens, but in that sense, that element should be enlarged in order to avoid some service disruption. Okay, please, next. So in this case, we propose to build the domains with some solution based on NFV, so we can easily increase or decrease the resources assigned to every part of the system, in order to react to, as I have mentioned, to changes, dynamic changes in the environment, especially when it was the resource required, no, the number of users that are attending one service is increasing or decreasing. Yes, please follow. So then we propose to introduce one engine that is interacting with every part of the every controller of the network, or network controllers, and also virtual machines controllers, and especially in this case, that engine will also interact with some detectors that we can call sensors, like for example a seismometer, that will report that something is happening outside. This can also be fed by big data information, but what we have more targeted right now is just one kind of external detector that is included. Yeah, please follow. So, and we have called this the autonomic resource control architecture, and it will collect that kind of information from multiple places, like, as I have mentioned, controllers and also detectors. And then it will analyze it in order to find out what is happening in the system. After that, it will adapt the resources on the system, just communicating the new set of resources that should be assigned, communicating it to the controllers. In this case, a new function can be deployed in a new place in order to balance, no, for example, the demand of users and things like that. So, and after that, our intention is to achieve that in less than 1 second. That means that to adapt the system, the whole system, not just our controller or things like that, but the whole system in less than 1 second. But it is difficult. So we have found that some problems, like for example, we have too much observations. They had a real lot of information to analyze in a real short time. So we have to filter or apply different techniques to decide which information is interesting and which information is not. And also we have to apply a high performance controller in both in our side and also in the underlying control side, because we have also to reduce the delay, and especially we are now researching how to apply learning techniques to anticipate actually anticipate the resource demanded to the situation that is actually happening. And finally, it requires some reliability to ensure that it's working as the administrator wants it to work, because this will be an autonomous service. So administrators must rely on it, so it should be reliable. Yes. So this is the overview of the system. Please continue, Diego. It will exploit some automation techniques, like to minimize human involvement. And in this case, administrators will set up the operational boundaries of the system by providing some set of statements that determine the amount of resources that can be used by the control system to assign to the service, and or like for example the lower and upper load thresholds, like in a basic threshold-based controller. Please. And it will also separate every component will be separated in a microservice, so it can be pluggable, and also, of course, it can scale up or down as needed. And it will also remark the closed loop effect. That means that after one decision is taken, this controller will check that the desired objective of that decision are being applied to the network. Please. So finally, it will be supported as many other systems, like with some knowledge base, and supported and reinforced with the common ontology. Please. And now I will go to the most interesting part, and how this is related to NFV, and especially the management and operation defined by ETSI, etc. Well, what we place our engine in the situation of the virtual infrastructure manager. Well, and we have explored that, and we have one implementation that is interacting with other elements of the system, like for example, we are using the ORBI interface in order to transport this kind of statements from administrators, and in this case, the NFV orchestrator, to our controller. And we are also using, on the other hand, the Nfvrg infrastructure interface that we have adapted to include also the interaction with external elements, not just resources that are part of the NFV, in general NFV structure, but also external elements like I mentioned, this kind of seismometers. Please. So as I have mentioned, this is the role played by our engine, and also we have. As I have mentioned, the interfaces, but we have left out the BI, BNFM interface because it is out of the scope for now from our objective. We have experienced it with this OpenStack physical deployment, and we have, as I have mentioned, we have extended the interfaces to enable the interaction with external elements, etc. Please. And as to conclude, we have just design this infrastructure to provide the functions of this BIM, and we have extended interfaces, and we have achieved good performance in the OpenStack deployment I have just mentioned. And in using that deployment, we have a better view or a detailed view of the overlaying and also underlaying infrastructure that will be involved in this control process. And it allows us to get some production results, so it will be easier to transfer this. Our findings will be easier to be transferred to the production, real production environments. And we hope to benefit a set of stakeholders like that are especially interested in the efficient use of resources, like for the reduction of the CAPEX and OPEX, as many of us are familiar with, and also benefit both infrastructure providers and consumers. That means that in many market operations, it would be interesting to provide some function, in this case like control function, that allows providers to exploit their infrastructure, but also to allow consumers to optimize the resources they are using. So our next steps will be to, of course, keep reducing the time required for this control to perform the analysis, and also to increase the validation scenario, as I have mentioned, the basic use case, to increase it with other additional use cases, and align it with additional requirements from NFV SDN, like, for example, figure out how to integrate the missing BI, Nfvrg interface that we have to provide in order to fully integrate our approach within the NFV Mano scheme. That's all.
Okay. Oh, sorry.
So I saw that you, Sarah Banks, NetScout, I saw that you just mentioned that one of the things you want to address is the VI, VNFM that's not there. I'm just curious, it seems like a really large part of a use case that would be useful now, D1. Why is it out of scope in your initial pass?
Because it's not out of scope of our objective, it's out of scope of our current target. That means that, why? It's because we are doing we are building the architecture gradually. Based on real implementation, and we are leaving some interfaces that we initially can consider second degree. Like, we are more emphasizing the interface with the orchestrator. We thought it was more interested to have that before having the other interface to the middle layer these elements. Sorry.
Thank you.
Any other question? I'm curious, how do you differentiate this from things like OpenStack Congress and this kind of policy managers that are already available for cloud orchestration systems?
Yeah. We have started working with that kind of solutions, but the problem is especially our target to include information from the outside. That means, like, our final target would be to anticipate to some event. That means that in some moment we will include also big data information. And that is a problem with current implementations of these console solutions. So for now, our main target is not actually react to increases in the load, of some element. No, it's to react to something that's happened outside. Even though we can fail and then nothing happens. Like, for example, things that in this use case, we have this help desk, and it will be and if something like a strong storm, earthquake, or tsunami or something like that happens, it is supposed that many people will contact this help desk to get help, to inform something wrong has happened, something is bad, etc. Well, in the past, we can see some experiences where help desks were totally broken after that because they were overloaded, etc. And it is we have two solutions. We react and add resources, or we just that. And what happens in this solution is that some people can be unattended because we react after the system gets overloaded, or etc. Or we anticipate to the load and we increase the resources before. That's the problem that current solutions are not able to provide. Even modifications of them cannot be able because they have to deal with information that is totally outside from its normal working domain.
Okay. That's part of the, ambient sound. Wow.
Ooh.
Okay, so, well, this suspense, those suspenses, thank you, Pedro. So, next one is, the next one in line is Stuart Kleiman. Sorry, Stuart Kleiman from UCL. I'll be opening your presentation right away. One second.
I've taken time off from my job as a door closer to present some slides.
No. Okay, here you go.
Hold on. One. Is it on? Yeah. Right, I'm Stuart Kleiman from University College London. I'm going to be presenting some slides about some work we've done that takes a slightly different view on NFV deployment and the structures in which we can actually deploy these NFV elements. Okay. Excellent. So basically what we've seen is there's a lot of stuff you can do, a lot of elements involved in NFV, but the observations that some of us made in our group is that there's this quite interesting work going on in the network slicing part, but often the architectures presented and the diagrams had all the NFVs, should we say, executing in one data center. So there are a bunch of attributes that you could apply to the network part that weren't always maintained in the elements which actually ran the network functions. So in our mind, there was some kind of dilemma. How do you maintain all these things? And the stuff presented in these slides tries to address some of these issues and tries to present a symmetric model and also some level of abstractions that provide a level of consistency and control to maintain all that. Okay. So overall, we make this case in the slides and the work that we've done for creating VIMs on demand rather than having a single VIM for a data center. So basically, we suggest you should be able to create a data center slice as easily as you can create a network slice, and that if you create this data center slice, then this new slice should actually have its own VIM, not the one that was originally came with the data center. And later on, we'll show some of that and some of the architectural elements that are a consequence of doing that. Okay. So this is the basic model we're trying to do. We have some kind of orchestrator. It has some model of what a network slice could look like. Up there somewhere, little green line. Is there a pointer? My finger's not long enough.
This should be a pointer.
Yeah, right
This
there.
should be a pointer, right?
I'll give it a go.
Yeah, this is a.
Oh, this one?
Yeah.
So that looks green line. Is it easy to take this out? How about that? There we go. Look, I can do it like that.
The idea, Stuart, try to stay as much as you can on the pink,
Oh, yeah.
because people watching on the.
On live, yeah, okay, sorry. I'm too used to walking around the lecture room, pointing. Sorry. There. So inside the orchestrator, it
No,
will have
but-
some representation.
May I recommend just hold the mic on your hand?
That's all right, don't worry. It's
No,
okay.
because if you're going to turn, it's
Oh, yes, okay. So then we have the orchestrator with the representation of the slice, and in essence, it wants to deploy a service onto that slice, whatever that means. And we have something where there's this representation of a slice in the orchestrator, and we actually have the slice elements. There's some data center parts, there's some network parts, and the little green squares represent the VNFs that are part of this whole representation. And these run on the physical resources inside the data center, the network. Okay, so what we've seen is, yeah, there's many slicing models, and they slice the network, but like I said earlier, the NFV elements happen to be scattered across the data center. What do we mean by scattered? Well, it could mean a whole bunch of things based on various policies, requests to the Vim from the orchestrator. But in essence, the data center is one big fat shared resource, and it doesn't maintain the same attributes that you could apply to the network. So here's a nice picture. We see from some physical level, I've got a data center with some stuff, and they're connected by networks. And yes, there are a whole bunch of mechanisms for creating sliced parts of the network, and part of this is already being done in the IETF and also IEEE. It's all coming on. Next one, please. And then what we're saying is, well, we should have the same capabilities inside the data center. We should be able to do slicing with some attributes. Okay. And once we have these parts, I've got some network sliced parts, I've got some data center sliced parts. We have to connect all the bits to represent the single slice, end to end, spanning some geography. How this is done is not always obvious in all the cases, but in essence, it needs to be done properly for full network slicing and service delivery to happen well. So just want to go through a few ideas, definitions of what these elements are. So we say a DC slice, it's an abstraction over the data center, okay? And it represents a collection of resources of the data center, and it can be, more importantly, controlled and managed separately from the other slices inside the data center, much like the network sliced parts are managed independently of the other network slices. Okay, and this is different from having one big fat data center, right? Okay. So we say a DC slice can be managed, allocated to any data center, and this could be big data centers in the center of the network, some medium-sized ones, or even at the edge, because there are various cases where I might want an independent slice all the way through the network, from the mobile edge all the way through to this core network doing a lot of processing, and it should be independent of the other parts. We also say, well, once you have this, now it becomes a basis for the control in these virtualized elements. I now have some underlying system. I can now put my own virtualized bits on top of it, okay? More excitingly, we can say, well, the slice isn't fixed. Now it's soft and dynamic. It can also be elastic because I have some control over it. I can ask someone, please make my slice bigger, data center slice bigger, please make it smaller to match demands, because the data center will be bigger than the slice itself, and hopefully the data center will have enough spare resource to allocate a little bit more or take some from us as needed. Okay, next please. Okay, so what next? Now we're kind of coming along going, oh, this is quite interesting. Well, because the Vim is going to be allocated on demand, we can actually choose any kind of virtualization we want. We're not fixed by what the guy at the data center chose to deploy when he picked his favorite bit of software. He might go, oh, well, I want OpenStack and I want this module, that module, and I want to do it like this. Well, if I'm allocating my own slice and I have my own Vim, I can actually choose what kind of mechanism I want. So we've got here, you know, Zen, KVM, maybe have containers, doesn't matter. But the consequence of this is that it's now a customer choice. I can actually go along and say, I would like a slice, and I would like you to deploy this Vim, not that Vim, because that's the one I want. Now that gives you a very different model, and it gives you a lot of flexibility, okay? And the other thing is that if the system's set up in the right kind of way, then because it's your Vim for you to use over your slice, your hosts, you can control some of it. Obviously not all of it, but there's a whole bunch of stuff you'll be able to do with the Vim for your slice that you can never do at the moment. Okay? Yeah, okay. So what can we say? We're saying Vim needs to be allocated on demand for each slice, but we need some kind of management component that can actually allocate the slice and, as a consequence, the relevant Vim. The slice owner can manage, configure, control their own Vim, and that Vim could be any kind of technology that's out there. And we see that if this is deployed, the actual data center itself can actually have a catalog of Vims. They can tell you, we are able to deploy this kind of Vim for you from our pre-existing catalog. Because the Vims can themselves just run in virtual machines, ready to go, to be instantiated. Okay? Now, the next point is, well, some of these Vims are quite big, and this is a kind of secondary issue. If you allocate a slice on demand and you then allocate a Vim, where do you put the Vim? And this is some secondary work that we've done that isn't part of these slides, but the Vim elements themselves need to be placed somewhere, and there's a good chance in a commercial setup, you'll be billed for your Vim because it's going to be using some resource. Okay. Next, please.
You have this lady waiting for you.
Oh,
Is it possible just to ask a short question for clarification?
Norit,
of course.
can you say your name?
Yeah,
also?
sure. Norit.
I have,
Norit Sprache
I have
from Nokia.
answers, but not to all the questions.
Yeah. Just a question for clarification. So you actually assume that you need a Vim per each slice, and I don't really understand why this is the assumption. For example, thinking about a regular network, and we have multiple VPNs, so do we have a network per VPN? No, we have one network which is shared between multiple VPNs, right? So same here, one Vim can be shared by multiple slices. So why do we need a Vim to be allocated per each slice? And in my opinion, and again, you may get to that later, as much as we make the slice awareness at the upper levels, we get it much more simplified in the lower levels. But okay, but maybe you can start just clarify the assumption here.
Oh, okay, yeah. Yes, there's nothing in this presentation that assumes this is obligatory. So if you have a scenario where having some shared data center and using the same Vim and same resource as everyone else suits you, we're not saying don't do it. What we're saying is there are some scenarios where you want some guaranteed resource and you can ask the network to give you some guaranteed resource. In the current setups of data centers with Vims, you have no mechanism for absolute guaranteed resource, completely isolated from the other people, where you control the hosts. In the old days with data centers, you'd rent the hosts, and you got your hosts, that's it. And that's at one end of the spectrum. And now you have these data centers where there's the Vim, something like Amazon provides Google. You talk to one entry point, you say, give me some stuff. And they're kind of the spectrum. And we're saying there's an intermediate point for certain resources, some telecoms resources, IoT situations, certain network services, where you want this intermediate model and it suits you. For many people, it doesn't. If you're deploying one web server and one database for a small application, you just don't need it. And this kind of scenario isn't relevant. But there's others, you know, I speak to a lot of the telecoms guys in some of our projects. This kind of situation's ideal for them, where they want the data center, they want to have some kind of flexibility, but they also want to be isolated from the others. Yeah. Does that make sense? Yeah. Okay. Next slide, please. So then we come on to the slice control. We call it the slice controller. This is the element that you talk to request a new slice. You ask the slice controller, I'll get to the end of this and I'll answer your question. Or do you want to ask it now before I go on? Yeah, wait, okay. So we ask the slice controller, please give me a slice of this size, and can you please allocate a Vim of a particular type? So the slice controller will arrange for that. Once it's done, you'll get a handle back on your Vim for your slice. Okay. But the important thing is that in your slice, your Vim cannot manage hosts that are part of other slices. They're isolated and controlled. Yeah. And the slice controller, because it's the element of control, it is the one that has the capabilities to add new hosts on the fly, add new ones, remove hosts from your slice. So we say at the bottom there, slice access control is important.
Carlos, another short question. I guess that you are talking about one beam per slice, but nothing prevents to have multiple beams allocated to one single slice, right?
No, nothing. Yeah, nothing prevents it, I guess. Yeah. I mean, that's a model was you'd probably want one Vim for a slice, because a slice could be as small as 2 hosts. Or, you know, I mean, in reality, probably wouldn't. But if I said, please allocate me a very small slice, would I allocate 2 Vims? I don't know. I mean, but there's no, I mean, that might be outside my head, that scenario, but in reality, there's nothing to stop it. Yeah.
I was thinking of multi-technology kind of slices where you may need multiple beams to be able to control, because there are different type of resources. So
then I think you'd allocate 2 independent resources with the different things and then rely on the other technologies for the connectivity. Yeah. Okay, next one, please. So in the next few slides, I'll show a kind of pictorial, structural view of what we're aiming for, or actually built, but yeah, go on, please. Yeah. So we say currently we got this 1 Vim per DC. And this is the kind of scenario you have. You have the Vim, it talks to all the hosts. And what happens is, as we've seen over time, the Vim gets more and more functionality to do more and more stuff. And then people go, oh, this module doesn't work. Oh, they updated that module, but that doesn't work. And I don't need the Vim to do this. Oh, you need it. Anyway, so that's what happens at the moment. And then what you have is, well, I've got this 1 Vim. People try and deploy services over it. And because you mostly have very little control, the service elements, VNFs, whatever, which are colored in yellow and green here, they get allocated to wherever the Vim wants to put it. So we can see that, oh no, this host here has 2 functions in it, and there's no isolation, and these guys might really want it. Okay, next please. So one model is to say, well, we'll extend the Vim to do some kind of guaranteed stuff. It'll make it look a bit like a slice. And it's an interesting model. And I think there are elements of OpenStack that will try and do this to isolate the things. But of course, you're still stuck with this issue that you've got 1 Vim, which is fine. But then you've added even more functionality to a thing that already has a lot of functionality. And the person that requests the slice still has no control over any of the policies, any of the control. It's still someone else's issue. Okay. So this is why we say, let's try and go for this model, one Vim per slice, and we have this flexibility of being able to control it as the customer. And so here's a representation from earlier. The little blue blob with the yellow slice represents this thing here. Okay. So at UCL, we've built a proof of concept of this slice controller. We use some technologies, lightweight technologies for virtualization, just to demonstrate that it actually works. So I built a slice controller, has a REST interface. We can make requests for various slices. It allocates some hosts from a pool of servers and then allocates a Vim on demand as needed and passes back the URI of the allocated Vim back to the caller. And then the caller can then do whatever it wants in terms of placing virtual machines onto those allocated hosts. Okay. So it kind of looks like this. We have this slice controller. It actually has a catalog of all the physical resource. And when you make requests for the slice, it allocates the Vim, as we said. Yeah. And as you keep doing stuff, you get more slices, more Vims. But of course, we can see that the elements are genuinely isolated from each other. So now, just to finish off, I want to give a more of a overall high-level view. Where do we go with this? Okay, so now we have this slice that encapsulates network parts and DC parts, and it's connected. Yep, next please. And we've got Vims for the data center part, but nothing for the network part. This is my observation. As my background, I used to teach operating systems and compilers. I noticed that there's no element for talking to the network. I can talk to the data center. There's no equivalent for the network part. So we say, well, maybe we have an equivalent. Might be quite simple to start with, but maybe it's there because we can do something with it. Next one, please. So here I present more of a stack of abstractions of what we can do. At the bottom layer, we have the resources, the data center, the network parts. We see that slice controller that can allocate new slices, and it gives you, oh, hold on, the button's still, oh, there it is. So the slice controller talks with DC. You get a slice partition of the data center. We already have some mechanism for taking the network and getting a slice part. I don't know if it's called that, but it can be. For the data center part, we have Vim. For the network part, some equivalent element. Maybe some exist at the moment. I'm not 100% sure. People can correct me if I'm wrong. But then we can go, okay, so I've got my network slice part. I've got my DC slice part. I've got my Vim for talking to my DC slice, and I've got my little NIM bit. And now I can have a full representation as an abstraction of all these parts inside the orchestrator, and I have a point of control and interaction with all these elements. Okay, next please. And that means the orchestrator can now deploy on this full slice, aggregated slice, by talking to these elements to get stuff done. These can act as control points and measurement points, getting stuff back. Next, please. Yep. Okay. And then we have, once we have deployment, we can see the things being deployed. Okay. We're getting towards the end now. So next. So conclusions. So yes, there are some scenarios where we believe it's quite important to have these separate slices. Presented the case for why we think it's useful and beneficial and showed some of the elements. And as you just saw, there's some kind of layered abstractions you can build up on top of this to give you a more functional system overall. And so, yeah, bigger picture for control. And it is appropriate for use where you're kind of using clouds for networks. when things were separate, some of these models people thought maybe not so much. But now there's this idea of NFV and isolation and slicing. We believe this is a really important way forwards. Okay. Yeah. So finally, yeah, there's a lot of further work, particularly in terms of standardization, APIs, mechanisms for interaction. But what we can say at this stage is it does work because we've got it working. And if anyone else is interested in coming along and doing things with us, we'll be interested in doing that. Okay.
Okay,
Thank you.
So you have,
Any questions?
no, you have
Hi, Stuart. Arthur Hecker from
an anxious
Huawei.
line.
So, short question to the model.
Yes.
Arthur.
Is the VIM
Arthur.
part of the slice,
Well,
or is it part of the infrastructure that is being sliced? So what I'm asking is, who is the tenant?
You're asking, sorry, who?
Who is the tenant?
Who is a tenant? So I'll give an answer. We see that well, because I didn't bring my other slides, it's hard to say. But in essence, we saw that the Vim that you allocate for the slice is in essence part of the resource that you're utilizing. So if you're the customer of the data center, you ask for the resource for the slice, but your Vim that gets allocated is yours as well. So in essence, that's something
Vim
you'll be
part
built.
of- Is Vim part of the slice that I get, or is it allocated within, let's say you're giving
We
me-
actually have two models. We actually have two models for how this can be done. One is the Vim elements are deployed into your slice.
So if it's the case, then I can immediately say, you don't need to do it, I can do it myself, right? I mean,
Except
you
you
give me
don't have a
resources,
control-
I could be deploying an OpenStack in these resources. What do you care?
Possibly. The other model we had is that we reserved a whole bunch of hosts in the data center only for the deployment of VIMs for other slices. So if I asked for 16 machines, you really got 16 machines and your Vim was outside it in this pool of hosts for VIMs. I didn't present them here because it's obviously limited.
So, okay,
to-
then nobody else can use those 16 machines, right?
Yes, but that's still true with, yeah, in
So
either
that would be-
case.
exactly, that was essentially the leading question to the actual question that I wanted to ask. If you have several VIMs, which are running in the infrastructure, shouldn't you be somehow treating the question of conflicts? If two VIMs can essentially handle the same resource, which ultimately will be the case in this model, unless you do some kind of hard slicing, which
No,
is
no,
less-
in our model, no single host can be managed by more than one Vim.
Okay, but then it's essentially like making a smaller DC out of a big DC.
Exactly. Yeah, absolutely. Yeah, absolutely. So you get a kind of virtualized DC. Yeah, exactly that. Yeah.
Marco Liebchen is here. I have a comment and a clarifying question. So the clarifying question actually follows up on what Arthur just addressed. So the comment is more, now if we introduce in this picture the user of a slice, or
Yes.
multiple slices, which is, sorry for using that term, the tenant, right?
Yeah.
So I understand advantage here is that you expose more control to the user of the slice to organize its slice, right?
Yes.
So then I would rather say that one Vim per tenant is what you're looking for, not one Vim per slice, because I think that the tenant can use one single Vim. It doesn't need to have multiple Vims or coordinate to manage its slices, right?
I guess it depends who is requesting the slice. If you're a telecoms company and you're doing some kind of end-to-end application, you might allocate the slice for the telecoms guy on the basis that they may have clients who are the tenants of that slice. Yeah? So that you actually get a different layering of who's the customer, who's the tenant. At the moment, when you have one big data center with one Vim, the tenant is the telecoms guy or even the end user, because he's the one that makes the request. In this model, we separate out the Vims because now the telecoms guy now owns the Vim temporarily over some long time period, and he himself can have separate tenants inside the slice. So you get an extra layer of owner, tenant, whatever. Does that make sense? Yeah.
And so in the view of exposing more control as a front end to the customer, you may use brokering systems or something. In the past, we investigated something similar to this concept, which is, well, Mono as a service, right? So you expose the full NFV Mono plus Vim to the customer. But as Arthur also said, I also assume that the VNFs, all VNFs of multiple tenants are onboarded on the same shared infrastructure, physical infrastructure. So you need some level of coordination. So you need a kind of master Vim in that case to coordinate, just to avoid or resolve conflicts.
Yeah, I mean, yeah, it depends on the use case. That's what I said earlier, and the lady asked me a question. We're not saying some of this is obligatory. It just gives an extra level of flexibility and mechanisms for control and abstraction and layering that the current model makes rather difficult. Yeah. Okay. Yeah.
Peter Ashford Smith, Huawei. I think I'm asking or making the same comment as the first questioner, a slightly different way, but optimization, if you sort of partition into different subsets and individually optimize across those subsets and try to combine the result, you don't get an optimum, right? You need a flat set of resources to optimize over. So I'm just, the point being that you could never actually fully optimize all the resources within the entire data center, right? It's recursively optimized within each one. Is that what you're getting at?
No, more that individual data centers across a large geography could have individual slices, so that your slice that we had as the green line with the blobs is not within a single data center, but is pan-geography, so that...
The point being that your logical data center could optimize itself, but not with respect to the others. And the point...
Yes, absolutely.
So there's no statistical gain across the individual slices.
Yes, and in fact, someone else asked me a question a few weeks ago, and they were like, couldn't this possibly use more resource because you pre-allocate and do stuff? And the answer is yes. You're now trading off a flexibility and control and policies that you pass up to the customer that they never had before versus some potential extra resource usage. And that's a trade-off for the customer, because they may go, I don't want to spend more money by having my own boxes. And we go, that's fine. There's an existing model that already works for you. Others may go, for me, the isolation is far more important and the flexibility is more important than spending a few more dollars over the year.
Yeah, as long as you're aware of it.
Yeah, exactly. Yeah.
So I got the requirement.
Can you say your name, please?
Sure, Mohammed, Vichar Communication. So the part is a little bit distracting, and I'm going to ask you the question. Are you looking at each individual Vim separate from each other, and are you guys at like a higher level Vim on top, or you just had the orchestration to spin up the different Vims for the different slices?
Again, nothing obligatory. We're saying that here is a model that extends what's there. If you want to have 3 slices that happen to have 3 Vims, and you want to put stuff on top, that's up to you. We're just saying, here's an extra level, here's some more stuff. Once you've got your handle on your Vims, you're the application guy, you're the customer, you do whatever you want.
I understand that, but my point is, so look at data center. You're talking about the slicing the data center to separate Vims.
Yeah.
Now, the question I have here is, what is going to be on the node? Are you envisioning it some kind of Vims driving, or are we going to think about some kind of orchestration driving that I'm start doing more Vim slicing? Because if you think about the orchestration to build those Vims, okay, fine, we all can do it. The matter is going to become, is it easier to have that upper Vim build that visualization and then nest your other Vims under that, so you actually get optimization for your data center and also create those slices as a nested to the top layer Vim. Does it make sense?
Yeah. I think there's different ways of doing it.
Okay.
I mean, it's a possibility, Yeah.
Anne Flink, Nokia. Just to complement what he was asking, this was a bit difficult presentation to me, especially what seemed to be missing from my perspective was the relationship to the monostack. And if you are able to show how this relates to the monostack, I think you are answering his question that what is on top of Vim and how the Vim is in the monostack in relationship to orchestrator and
the relationship's identical. It doesn't change any of those relationships. The only thing it changes, which you don't see in the Mano specification, is this idea that the Vim is dynamic. In the Mano spec, you look at it, and there's one of them, and the assumption is it exists in advance. There's no concept of it being dynamic at runtime and being elastic. The other stuff stays the same. All we're saying is this Vim can be allocated at runtime, and you will get the layers above will get a handle on it at runtime. You don't have to know about it in advance. What you do need to know about in advance is the slice controller, because you have to have an element to talk to then allocate the resource and the Vim to get a handle on it. So a lot of the stuff in the slides is all these things are dynamic. You can't assume I know the endpoints of the network. I can't assume I know where the Vim is. I can't assume anything at all. Maybe where the slice controller per data center is. You have to build the stuff up from dynamic elements based on the data that comes back to you at runtime. That's it. Yeah? Okay. Right.
Peter Ashwood-Smith, Huawei again. Thinking out loud here, so hopefully this will come out correctly. If you sort of physically isolate a set of logical data centers, so the resources are isolated, if their output and input aggregates into a statistical multiplex pipe, how can you trade off between the two through that pipe if you don't know what's going on within those individual data centers? Doesn't it imply that you would, in order for this model to work end to end, that you would have to have actual physical boundaries for the bandwidth between the two data centers? In other words, TDM or DWDM? I don't know the answer. I'm just.
This whole work's been predicated on the idea that there's network slicing. Yeah.
Right, but
whatever that manifestation happens to be.
We have DWDM, TDM, and StatMux, and right.
There's a bunch of others I've been told as well. And so the actual technology of the network slice is not a feature of this. So this is the idea of why do we have this NIM, this element to talk to the network? Because you need an abstraction point for the higher level up to isolate the network slice, what should we say, actual technology.
I guess my point was that you have these guaranteed bandwidth, guaranteed compute pools that you're connecting to each other through if you connect them through a shared resource StatMux packet, you have to know how much is going from each individual pair, and you have to have isolation mechanisms.
Well, from my understanding, the network slicing provides, that is the purpose of the network slicing, to provide the isolation. The bit you need at runtime is the endpoint stuff, and you need to know the attributes of your slice, and you can measure it at runtime.
Well, the purpose of slicing is not necessarily to guarantee complete isolation across all the resources. It's to create that illusion, right? So that things work, so that they get the right QoE and the QoS. If you have to do that by physically isolating all the resources, you may as well just build multiple parallel networks at n times the cost. The idea is to get statistical gain through cloud and cloud technologies wherever you can. So it's not just physically isolate everything and away you go. That's sort of the easy answer. The cheap answer is to share when you can and isolate where you must. Right? Yeah. So I was just asking how that, if you physically isolate in some places, but then they aggregate and share, that requires some coordination. And I don't know what the answer is.
I don't know. I mean, it's similar like saying, well, I run multiple TCP streams across the network. Right. What does the guy up there have to know about it? He doesn't. I write programs, I open TCP connections, stuff goes. the application never sees it, right? At a certain level of layering and abstraction, the guy below deals with it and it works or it doesn't, yeah? I think the same would be true in this model. There's a certain layer low down through various controllers you're not going to see.
The TCP is probably not a good example because it converges to proportional fare at some approximation of proportionate fare, which is not necessarily the right ratio for slices, right? But anyway, I don't want to.
No, we can talk about it more later. Yeah, it's an interesting point.
Issue.
Yeah, definitely. Yeah.
Yes, it's Alex Gallis. I'm from UCL. I'm not going to ask you a question from a manager.
I think we've met.
We met. But coming back to the previous point, is that one of the needs, or the main need for slicing, is not to partition resources. It is to create an environment where separate services of qualities are run somehow under control of the tenant. That implies a partition of resources, but that's to some extent the needed part. Now, and I hope that that answered the previous question. At the end of the day, the slices are not for full isolation. This could be done many ways.
Yeah, sure.
But one of the issues here is that we are moving out from very large data centers towards micro data centers or network data centers or data center at the edge where actually most of the functionality could be put in, including virtual functionality. In this scenario, when you have a lot of edge data center interconnected, and that's where you create your slices, this type of slices, under some level of control. Automatically, that requires maybe a slightly different model of control and management of it. What will be your comment how to move to this large-scale sort of micro data center interconnected scenarios where things will be moved? In other words, NAV moving to the edge in practice.
Yeah, I mean, no, I agree. And it was mentioned in the slides, we have edge. I don't see it being the edge data center would undermine the conceptual model of what you're doing. The fact that you might deploy a different Vim, have more lightweight virtualization is still part of the, it's a model, it's not a particular implementation or technology for doing it. So yes, I agree. And that's why I said a few times, end to end is where it's at to make the full slice happen. Yeah.
Well, before you can consider dismissed, a couple of questions.
Okay.
No, Nurik, if you want to, no. It's no. First of all, is that I see this idea of deploying a Vim. Fine, I mean that's but taking into account how much an instance of OpenStack, for example, weighs. Well, that precisely having it up and running is not precisely a trivial task.
No.
Which are your experiences with that? I mean, would not this call for much more lightweight cloud managers?
It depends, I think, on the time scale over which you want your slice. If you think, I don't know, everyone says CDN, right? Oh, I want to run CDN to here and there. I'm assuming it's not going to run for a few seconds. Right? Your time scale over which you want to maintain this bit of slice is quite big. So if you're prepared to wait some minutes to have some resource for days or weeks or months, it's a minuscule percentage of the lifetime. If you think, like Alex said there, it's going to be at the edge and some people are going to be there and we need it for half an hour and we just want to allocate it because some people are there and it's going to go away, then yeah, starting OpenStack will be a significant portion of the time at which you have the slice.
And the resources.
Yeah. the resources. So yes, and this is why I said to Alex, this is a model for doing stuff, not a particular implementation. In different instances, in different data centers and different lifetimes, you would choose the technology to match the requirement. Yeah? Does that answer that?
Yeah, no, I mean, but this is one of the things I have had in mind for quite a while, that in general, cloud managers right now are overkilling in general.
But that goes
and
back
this is
to my,
something that very much connected with the reflection that Alex was mentioning. It's if you have a huge data center with millions of nodes, for sure it makes sense to have it. But in those cases, somebody should start thinking about a much more lightweight.
We have one at UCL. We've been developing it for a number of years. But why is OpenStack so big? Because the data center it runs on is big, and there's
and the time scales are
time scales and the functions, and we have more functions. Oh, we need to do that. It doesn't do that. Well, we'll just write some Python and a bit more Python. Oh, but it doesn't do this. Well, we'll add some more.
And who cares about 3 more cores?
That's all right. We'll just buy
machines,
another rack of top-of-the-range servers to do a tiny bit of monitoring, and all will be done. So, yeah.
The other thing is that I want trying to mix and match what Eduardo was presenting at the beginning and what you were introducing here.
Yes.
Because, I mean, I see them, both approaches moving in completely opposite directions. I mean, how you could try to implement something like the rethinking that Eduardo was mentioning about pushing functionality down to the switching fabric on the one hand, because right now if you have separate beams, each one of those beams will be talking to a SDN controller. There will be a unique SDN controller in the data center, and then it will be mediating and making decisions. What if you want to put some processing on the switches? The switches are going to be shared. I don't know. I mean,
no, I have an opinion. I'm glad you asked that question, because when he presented his slides, I was like, and when he was saying, oh, well, this bit's difficult, that bit's difficult, the OS guy in me was like, that's because you don't have enough abstractions. That's because you haven't abstracted away from the device to the control element. You're getting this guy to talk directly to the device. In the OS level, that's a device driver. You need the next level up that does the intelligent stuff to talk to a piece of software that talks to the device. So the bit where Eduardo said, oh, I've got a bit of network function in the switch itself, fantastic. What you don't have is a software representation of that useful function that's managed by something else. Because the bits he presented were really fantastic. I mean, it's like, yes, let's represent some network function in this device. But what is that device? It's a device where you send a sequence of instructions and say, please do this. Well, this is no different from writing some software on my laptop server, and the compiler generates the instructions, and the process is the abstraction that manages that runtime instance.
So that implies that in your slides that would include switches.
You would theoretically have an abstraction, a software element that could fit in to talk to.
And then you hit the limits he was mentioning about the inability to stack several switches in the.
You need more software. That's what you need. That's the answer.
or bigger hardware. Yes. At the end.
No, I mean I joke about more software, but
no, I mean.
But maybe there's some people in this room. I actually gave a talk some years ago it was at ICC about some lessons to be learned from operating system design and some history about how long ago these things happened. Because there's a lot of layers in all the boxes that everyone's using. There's a lot of layers before you get to the hardware. And there are some genuinely useful lessons to be learned about bits of software talking to devices and bits of software that multiplex, demultiplex, schedule, control operations down to the device that are genuinely useful.
Yeah, it's Norit again. I
Hello.
have to say that I share a lot of comments that were raised here in the room, and also when I heard you, Diego, I had the same feelings about who knows what. And it looks to me very much bottom-up approach, and I think in network slicing we should really look at that at a top-down approach to understand from even starting even with the business here, to understand what is slices. Again, there was a comment that they are not used in order to make isolation, but it has the purpose to create per service tailored network or whatever, with the quality of service, of course. And we need to understand what is the relationship here between the different entities, and then to know who can control what. And hopefully in a good design, the resource level is not aware of the slice. It just provides resources. All of that is handled in much higher levels. So, and there is a lot of business to business relationship here, whatever. So I think per Hannu's comment that it was a little bit complicated for him, I think if we could see that much more top down, I think we could.
That's what this tries to do. This tries to present a top-down view of, I'm the guy at the top, call him an orchestrator. I have some abstract model of the slice, and I want to deploy a service. That's the top level view, and it filters down through some stuff. Go on.
This is, in my opinion, detailed solution. It's not top-down approach, because you already decided where the slice management is and where is the orchestrator or whatever. You already created the hierarchy. You need to understand top-down how the function, from the functionality point of view, and then understand who is doing what. For example, what I'm missing here is the business-to-business gateway, for example, because network slicing is between different entities. So a lot of things are done and the end-to-end, and then what is done in domain-specific, this is the next step.
Yeah, I mean, like I said earlier, there's lots of slides.
Very detailed solutions. I expect to see much more on the functionality before we decide what is, of course, this is research, but I'm saying in general, what is done by whom and where.
That's one way of doing it. Yeah, definitely. Yeah. Okay.
Okay.
Any more questions? Anyone?
You want more?
No, but I don't know.
We have 8 minutes left, but I promise to have 7 minutes and a half for an open mic if anyone wants to. Well,
oh, yeah.
As you wish, you can stay there.
Oh, thank you.
So, no, that's, unless
thank you,
you
everyone.
have any
nice questions. Thank you.
No, but you have more questions for Stuart. We have 7 minutes and a half for any idea that you have, any proposal, any conclusion you can want to come, whatever. It's now is the moment. Okay. So don't forget the blue sheets if you have not filled them, and if you have filled them and you have them, please give them to us, or just raise your hands and tell us where they are. Where are the blue sheets? Come on. Oh. Okay, so
yeah,
we are done.
Yeah.
Thank you.
Thank you.